These are the 4.3 notes for trig. We're going to talk today about the quadrants of a triangle. So for the first example, if you have a point like 3, -4, we have to make sure that when we draw this triangle, it's oriented the correct direction. So over on the left-hand side, we're going to make a little coordinate plane. And there's 4 quadrants. We have quadrant 1 over here, quadrant 2, and oftentimes they'll write them in Roman numerals like that. So I'll try to write it occasionally like that, and the rest of the time just in 1, 2, 3, and 4. All right, so within each quadrant you have a triangle. Quadrant 1 triangle looks like this. Your theta, your angle is in the center, and of course you have your right angle on the corner. For quadrant 2, it looks like this. Again, right angle, and then your theta. Quadrant 3 looks like that. And then quadrant 4 triangle, just like that. So if you think about all 4 triangles together, I like to imagine they kind of look like a bow tie that you would wear around your neck, where this is the middle and then you have this bow shape around there. So when you draw triangles in either of these 4 quadrants, you have to make sure it looks like that. So for the first problem, example number 1, we have to first figure out which quadrant the point 3, -4 is in. So 3 is your x value and 4 is your y value. -4 is your y. So if I started in the center at 0, 0 and moved forward 3 and down 4, that would actually put me in quadrant 4. So visualize moving forward 3 and then down 4. Right? So you can kind of visualize where that would be. We don't have to get an exact location. We just have to know which quadrant that's in. So that would put us in quadrant 4. So what I'll do now is I'll actually draw the triangle in quadrant 4. The 3 would represent the x, this number right here, 3. And this 4, -4, would be that side there. And you can see that we are going down here on the quadrant, so that would be the -4, and here you're going forward to the right, so +3. Now we'll need to do the Pythagorean theorem to find the missing side. So this is my theta, which means this would be the opposite, adjacent, hypotenuse. And we'll do Pythagorean theorem, 3 squared plus -4 squared equals c squared, and we'll solve that out. Square root of 25 is 5, so that missing side is 5. Now the hypotenuse can never be negative, so I know that that +5 has to stay a +5. Now I have all 3 sides of the triangle, so it's time for me to write my final answers here. They're asking for sine, cosine, and tangent. Sine is equal to O over H. Cosine is equal to A over H. Tangent is equal to O over A. And there we go. All right, let's look at example number 2. Example number 2 is the same type of problem, but the directions are a little bit more lengthy. This is how they write the directions in Delta Math. So I want to make sure you had a solid example of that. If theta is an angle in standard position and its terminal side passes through the point -9, -5, that just means you're going to put it on a quadrant. So let's look at the point -9, -5. Let's see which quadrant that would land in if we graphed it. X is negative, Y is also negative. So you would go left, -9, and down, -5. That would put us in quadrant 3. Or again, if you'd rather, quadrant 3. Right? So we'll look up at our quadrant 3 triangle. It's this blue one right here. And we'll go ahead and draw a triangle very similar to that blue one. Theta right there. There's our right angle. And there's our quadrant 3 triangle. We'll put the numbers on that we know. So -9 is the x. That's always going to be the right-left movement. And -5 is the y. You can see it's a vertical up-down. And that does match because left would be negative. So as you travel this way, it's negative. And as you travel down, also negative. We'll need to find the missing side by doing the Pythagorean theorem. I've got some space over here on the left. I'll go ahead and use this. -9 plus -5. Square both of those equals c squared. Opposite, adjacent, and of course we're missing the hypotenuse again. Solve this out. Please do remember that when you square a negative number, it does become a positive. (106) is not a perfect square, so we'll go ahead and leave it as the square root of 106. Now we have all three sides labeled. Our hypotenuse is always positive, so we'll leave the radical 106 as a positive. And it's going to ask us for the answer to cosecant. Cosecant is h over o. H over O. And that's nice because we're completely simplified at that point. I don't have any square roots in the denominator, so we're good to go. Great, example number 3. This time they actually give us the quadrant. So they tell us right here that it's in quadrant 2. So we're just going to draw that triangle as a quadrant 2 triangle. Right here. Your theta, your angle, and then you can label opposite, adjacent, and hypotenuse. All right, and then we're going to put the numbers on for sine. Sine is O over H. That tells me that the 12 is the O, the H is the 13. Now be careful here because we have to check for the O and the A to make sure there's no invisible negatives. So let's make a little note. Watch out for invisible negatives. Anytime the triangle is moving or going to the left or down, you will have a negative number. So for this 12, I'm actually going upward. So that 12 is a positive. That looks good. Hypotenuse is never negative, so that's a positive 13. This A right here, you can see, is going to the left. So I know this number is going to be a negative. Now I still need to do Pythagorean theorem to solve it. Let's do that to the side. So I'm getting an answer of A equals 25, but because the triangle went to the left, like right here, because it's in quadrant 2, this is going to need to be -5. And that's what I mean by those invisible negatives, that one right there. Nowhere in the problem did we get a -5. We just had to know based on the triangle. Once we're done with that, we're ready to find our final answer of tangent. Tangent is O over A. All right, let's look at the next side. What if they don't give you the quadrant at all? What they're going to do is give you just a couple of clues about what's positive where. Now, based on the O, A, and H, as well as the quadrant being X's and Y's, we're going to kind of give us a little cheat sheet about what's positive and what's negative. So sine in this first quadrant is positive. cosine, also positive, and tangent, also positive. And that's because to get to this quadrant, you would have to go to the right, which is positive, and up, which is positive. Quadrant 1. All right, now for quadrant 2, sine is positive, but cosine is negative, and tangent's negative. And that's because you have to go left. Quadrant 3, sine is negative, cosine is negative, tangent is positive. So because you're going left and down to get to quadrant 3, both the sine and cosine will be negatives. Tangent's positive because tangent is O over A, and if the O and the A are both negative, that would create a positive tangent. All right, for the last quadrant, quadrant 4, sine is negative, cosine's positive, and tangent is negative. Think about how you would get to quadrant 4. You would go forward to the right, that represents positive, and then negative down, that would get you to quadrant 4. So you know you're going to have some negatives in there. All right, the thing about this chart is it's exactly the same chart for cosecant, secant, and cotangent. So you could easily, anytime you think about sine, you're also going to be dealing with cosecant. Anytime you're talking about cosine, you're going to be dealing with secant. Anytime they talk about cotangent, it's going to be the same side as tangent. So instead of having to write that out on every one, we're just going to kind of remember that cosecant and sine are paired, secant and cosine are paired, cotangent and tangent are paired. And then we have to remember our greater than and less than symbols. So this one is your greater than. And of course, this one would be your less than. And they're always going to tell you whether these are greater than 0 or less than 0. In other words, positive or negative. So this says, example 4, sine is greater than 0. Greater than 0 literally means positive. And cosine is less than 0. Less than 0 would be negatives. So I come over to my chart, and I want to look for the quadrant. There will only ever be one correct answer, where the sine is a positive and the cosine is a negative. Where the sine is a positive and the cosine is negative. That happens right here in quadrant 2. So I just write quadrant 2. All right, let's look at the next one. Tangent is less than 0. Less than 0 is negative. And secant, which really you really want to think about it being cosine, right? Secant and cosine are always paired up, and our chart only has sine, cosine, tangent. So cosine greater than 0, cosine positive. Look over to your chart. Where is tangent negative and cosine positive? And they have to be happening at the same time. So even though tangent is negative right there, your cosine's not positive. So that's not the one we're looking for. Happens right over here. Cosine positive, tangent negative. Quadrant 4. All right, example 6, cosecant, which really I'm looking for sine. Greater than 0, so I'm looking for where sine is positive. Cotangent, I'm looking for where tangent is positive. That's going to be quadrant 1. If this chart's not working for you the way we have it, feel free to go ahead and add each of those signs on. So call this cosecant, secant. You can even put a little slash there, cotangent, cosecant, secant, cotangent, if you need a little bit of extra help on that. That way you can have all 6 of them written there if you need it. All right, tangent positive, cosecant, which is really sine, is negative. Tangent's positive. Sine is negative. That happens in quadrant 3. And the last one, sine is negative, less than 0. Secant, which we're really talking about cosine, is greater than 0. So I'm looking for where sine is negative, cosine is positive. Quadrant 4. All right. Example number 10, which really should be example number 9. Typo. All right, 9 and 10 got switched around. Sorry about that. For example number 10, they're going to help us out a little bit. They're going to tell us the quadrant. So we're going to start by putting our triangle into quadrant 3. I've got some space over on the left, so I'm going to draw this triangle over here on the left. I will label O, A, and H. And then they're going to give me some information. They're going to tell me that cosecant is negative square root of 89 over 8. So square root of 89 over 8 negative. Cosecant is H over O. Remember, we said that the negative cannot attach to the H, so the negative will have to go on the O on the 8. So let's put that on our triangle. Negative 8, that makes sense because you went negative down direction. And square root of 89, hypotenuse is never negative. Then we'll need to find the missing side. A squared plus negative 8 squared equals the square root of 89 squared. Let's do this math. The square root and square cancel. Subtract 64 from both sides. Square root to get 5. Now, when we bring the 5 over to the triangle, notice the direction that the quadrant is in, that the triangle is in. Notice how this direction is to the left and then down. The negative on the 8 represents the down, but I need a negative on that 5 to represent the left. Invisible negative. Okay, now it's time to find the actual answer. So most of the work that you do here is in the setup of trying to find all 3 sides, label everything correctly. Once you get down to the actual answer, it goes pretty quick. Tangent is O over A. And because both of those are negatives, I can cancel those out and just get 8/5. All right, last one. This is again how Delta Math asks it. It's pretty similar. They call it angle A though instead of angle theta. We are in quadrant 4. Label the triangle O, A, and H. Cosine is A over H. I don't see any invisible negatives here. Notice I'm going forward. All right, so that 5 is positive. That looks good. Now I got to find my missing side. Pythagorean theorem one more time. Subtract 25. Get A equals 6. As I put the 6 onto the triangle, think about whether that 6 should be positive or negative. Think about the direction that triangle is going. Because it's going down, you'll need a negative on that 6. So another invisible negative. then at the very end, go ahead and find your answers. They're asking for sine of A. So sine is opposite. Oops. Guess I should write sine A. Opposite over hypotenuse. Remember, we don't want to leave our answer like that, so we'll multiply by the square root of 61 over 61 and get a final answer of negative square root of 61 over 61. There we go.